Welcome to SatTV, where I'm pleased to be joined by Dr. Robert E.Z., Director of Spaceflight Laboratory. Thank you for joining me today. Firstly, how is Spaceflight Laboratory's approach to developing satellites different from traditional manufacturers?
SFL uses the Microspace approach, which is built upon small, tightly integrated teams working closely together with reduced formality. This in turn leads to cost reductions and shortened schedules. Our approach is focused mainly on good design and extensive testing at all levels, rather than on part certifications and blanket process-heavy policies. We evaluate every aspect of development for the given mission context.
With 52 satellites developed and a combined 128 years of satellite operations, what technical innovations developed by SFL have had the most significant impact on improving small satellite functionality?
Well, I would say there are a number of improvements that we've made. We've introduced high-performance attitude control, which is a challenge with smaller satellites because of their lower inertia. And we have very mature, well-developed on-orbit verified attitude control technology, and we can adapt to different pointing needs for a wide variety of missions. We also have formation flying capability, as demonstrated by our CANX 4 and CANX 5 satellites in 2014. They demonstrated precise autonomous formation flying, and we brought the cost of formation flying down so low that it's within the reach of commercial missions and made them affordable. We have a modular power system that can support missions ranging from 1 watt to 1.5 kilowatts. So a wide range of missions can be supported with the same technology. Last but not least, we have a robust design philosophy. Our satellites are designed for reliability and robustness and generous lifetimes. We launch with healthy margins, and this typically results in longer operational life, better than expected performance, and of course, satisfied customers.
Now, you have a new line of CubeSat buses. What's so attractive to customers at this time?
Well, every satellite that we build leverages the same heritage core avionics and attitude control technology that we've been using in our missions for over 22 years now. So every satellite, including this new line of CubeSats, will leverage over 128 years of cumulative on-orbit heritage. So these are robust, reliable, high-performing CubeSats that commercial customers especially can rely upon to get the mission done. And so our CubeSat customers will be able to capitalize on these benefits, and they'll know that they'll be getting SFL quality in their satellites. Commercial business models are very sensitive to costs, and so that's why they use CubeSats in some cases. They use commercial deployers and aggregated launches. So having SFL quality in the mix will make a great difference in their outcome and in their success.
What about the types of missions? What applications are suitable for CubeSats?
Well, CubeSats can be used for a variety of different missions. Demonstration missions, for example, demonstrating new technologies. Disruptive missions where the end user is trying to open new markets and break barriers. But they can also be used for operational missions to deliver a service. And sometimes these operational missions are based on a replenishment strategy whereby satellites are replenished on a regular basis. So they can be operational but short lifetime. They don't have to be short lifetime. They can be longer lifetime, but usually this is how these CubeSats get used. Any payload can fit within a CubeSat, whether it's Earth observation, communication, scientific, or monitoring payloads can be used. And so there's no one particular application that CubeSats should be used for. Customers, if they can fit their missions, their payloads within these form factors, and they want to leverage commercial deployers and aggregated launchers, will use CubeSats for cost minimization.
So, Robert, tell me a little bit more about the accelerated new space development plan. How will it impact future space programs?
Yes, well, right now we're offering 2 different approaches to building our satellites when they're a CubeSat form factor. In particular, for our new CubeSat line, We're offering new space versus microspace. And the new space approach is really for shorter schedules and lower cost, even lower than what we're normally capable of providing, really to enable mass production of these satellites. And as you know, commercial missions now, especially involving large constellations, they're very cost sensitive. And so with shorter schedules and lower costs, business models will close much better than they otherwise would. So really this new space development plan is intended for operational missions that are based on a replenishment strategy and that have short or disruptive lifetimes associated with each satellite. This will enable low-cost constellations based on this quality control approach rather than a quality assurance approach. Quality control approach is really based on a percent yield of number of working satellites out of an aggregate collection of satellites. Quality assurance is more focused towards a single satellite that has to work. And so the new space or accelerated approach will allow customers to use a quality control approach in their development strategies, which are typically based on replenishment on a regular basis. Customers can still opt for our standard microspace approach in developing missions if they have a smaller number of satellites and want to ensure that those smaller numbers will work.
Now, you mentioned the Microspace Way. How does it support the development of successful missions with varying objectives?
Well, the Microspace Way, simply put, is a process by which we question everything that is done during spacecraft development. And we focus on those aspects that directly impact mission success. This is in contrast to the blanket policies and procedures that are typical of traditional space programs, which can lead to cost escalation and unnecessarily long schedules. In microspace, the focus is on good design and extensive testing at all levels. We really get into the details and try to convince ourselves of every aspect of the development process and its necessity. Microspace can be applied to any mission with any objectives. It is a flexible and adaptive and even sometimes minimalist philosophy rather than a standard. So it's not limited to specific missions or objectives. Microspace is not about taking blind risks, and depending on the organization, they may or may not understand this, but at SFL, we believe that microspace is not about taking blind risks. To do microspace properly, you must be disciplined in being able to distinguish between risks that are real and risks that are perceived or irrelevant for a given mission. And finally, a microspace engineer will never do more than what is needed, but will also always seek to do the good enough solution. Microspace is the art of the good enough, so to speak. It's developing solutions that hit the mark precisely without waste. And so in a nutshell, that's how I would describe microspace.
So finally, difficult times, but moving forward, what are the key goals for SFL?
The key goals for SFL is to continue to do what we've been doing, which is to service the worldwide community of end users that need satellites for various applications, whether they're governments, commercial entities, not-for-profit institutions, people that want data from space but don't want to do it at high cost. They want a low-cost mission that will fit within their budget. And we want to service all the emerging areas that we're now seeing, new space companies, small, large constellation customers that have need for low-cost satellites, but of high enough quality that they can rely upon them. So really, SFL is service-oriented. We don't actually have predefined what markets we want to serve. We want to serve everyone. And in that sense, we're able to adapt to however this market is going to change in the future.
Well, Robert, very interesting times. Thank you for joining us today.
Thank you. My pleasure.